Hi friends, greetings. Welcome to this our session. I want us to get the value of this definite integral. Okay? Yes, I want us to get the value of this definite integral. And please, if you're new to our channel, please help subscribe. Okay? Please subscribe to the channel and like all our videos. Share it with your friends so that they can have access to content like this. And in our channel, we offer courses in biology, chemistry, physics, maths, further maths, computer science, additional maths. Yeah, so we have so many subjects that we offer courses on. Okay, yeah. So please, without further waste of time, let's get started. Yeah. So I want us to evaluate this indefinite integral, and from the look of things, I see that if I think about the methods of integrations that I know, I see that clearly I cannot use partial fractions to solve this integral. Likewise, I cannot use substitution. I cannot use integration by parts. Yeah, so those methods seems not to be working. So what's the way out? What exactly is the way out? Okay, now as I'm seeing x squared plus 1 here, right, that's a nice hint for me to use what? A trig sum, right? Yeah, and since this is x squared plus 1, therefore now I can think about tangent, right? So I can use tan theta. So I'm going to let my x equal to what? Tangent theta. Yes, I'll let x equal to tan theta such that I'm going to have dx equal to what? Sec squared theta d theta, because if you differentiate tan theta with respect to theta, you're going to have what? Sec squared theta d theta. Now this integral now turns out to be the integral going from, now these are my x values, x equals to 0 and x equals to 1. So if this x becomes 0, I'm now going to have tan inverse of 0, which still gives me 0. If x becomes 1, I put it here, I'm going to have tan inverse of 1, which gives me pi over 4. Wait, so I'm now going to have the integral going from 0 to pi over 4 of the natural log of tangent theta plus 1. All that on x is tan theta, so it's going to be tan squared theta plus 1. Then, what is my dx? My dx is what? Sec squared theta. Sec squared theta d theta. Wait. Now, what is the nice way forward? Now, as I'm seeing tan squared theta plus 1, at least I know that tan squared theta plus 1 is equal to what? Sec squared theta, right? So I can just say this tan squared theta plus 1 and this guy they can negotiate, right? So this one turns out to be the integral going from 0 to pi over 4 of the natural log of tangent of theta plus 1 d theta. Great. Yeah, so what's the way forward now at this point in time? What's the way forward? As I see this integral here, I see the integral from 0 to pi over 4 of ln of tan theta plus 1. What do I do next here? What do I do? Think of it. Would it be so good to write this tan theta as sin theta over cos theta? Yeah, so let's just give that a try and hope for the best, right? Yes. So we are going to have the integral going from 0 to pi of the natural log of, we have sin theta, all that on cos theta plus 1 d theta. Great. So how do we proceed in? Okay, we can solve this fraction, right? We can adjust this fraction as the integral going from 0 to pi over 4 of the natural log of if we try to simplify the fraction, we can have sin theta plus cos theta, all that on cos theta. Great. Yeah, so what next? Now, I also see a log property which tells me that if I have the quotients of two functions in the logarithm, I can write it as the log of the numerator minus the log of its denominator, right? Yeah, so this one now can translate into the integral from 0 to pi over 4 of natural log sine theta plus cos theta minus the denominator, so it's going to be log of cos theta d theta. Wait. Now what next? Initially I had just a single integral. Now I have what? Now I have two of such integrals, right? And I'm saying this one that this is a single function. This is what? A sum of two functions. So is it possible that I can make this one like a single function? Check this out. I can see sine theta as cos theta. I can decide I might want to write it in the form, in a certain form like n or let me use r into cos of let me call this x, or no, let me just call it the same theta minus a certain angle lambda such that it is an identity. Okay? Yeah, so I can write cos theta in this form. I can write it in this form. So how do I get the values of r now and lambda? Check this out. I can get r to be what? The square root of the sum of the squares of the coefficients. The coefficients of sine and cos are 1. 1 square is 1, so just going to be 1, root 2. Great. And to get the value of lambda, I'm just going to have lambda to equal to tan inverse of the coefficient of theta over that of cos theta. So it's going to be 1 over 1, which just gives me tan inverse of 1, which is pi over 4 or 4. So my r1 and lambda, my square root of 2 and lambda is pi over 4. So I can keep this 2 in mind. So this one tells us the integral going from 0 to pi over 4 of the natural log of what is this guy equivalent to? Is equivalent to 2 cosine of theta minus lambda. What was lambda? Pi over 4. Great. Then minus natural log of cos theta, all that d theta. Yeah, sometimes some people can argue the fact that I must put a bracket here, but that doesn't really matter, okay? Yeah, at least I have this integral is this way, or this, then everything is theta, okay? That makes it right. Now, I have two functions here. I have a constant function of root 2, and I have what this cos of this input. So, I might want to split them into 2, okay? Yes, let me split it. So, I'm going to have the integral from 0 to pi over 4 of the natural log of root 2 plus ln of the second which is cosine of. Now, cos theta is an even function, right? So that cos of theta is the same like what? Cos of negative theta. So I might want to write this theta minus pi over 4 as negative of that result. Okay? It still remains the same because cos is an even function, like I said. Cos x is the same like cos of negative x, okay? Yeah, so I'll write this one as pi over 4 minus theta. Wait, this input, this function is still the same like this one, okay? Yes, this cosine of this is the same like this one, the same. Yeah, you can check that by yourself, okay? Then minus ln of cos theta d theta. Wait, what next? Notice that initially I had the integral of a single function, right? Now I have what? Now I have 3 integrals. That makes it pretty crazy. But I see that the root 2, that's the natural log of root 2 is just a constant, right? Yeah, so it's very easy to integrate. Now let's investigate how this guy looks like. Okay? Let's try to investigate. Let me put some notes here. Let's take a look at the integral from 0 to pi over 4 of the natural log of cosine of pi over 4 minus theta. Let's try to investigate this d theta. Let's do a nice use of, let's say our u is the input, that's pi over 4 minus theta. Therefore, we're going to have du toward negative d theta, right? Wait, that means that we're going to have now the integral. This is our theta values. When theta is 0, you will be going from where? Pi over 4. Wait, and when theta is pi over 4, you will be going from where? From, right? Of the natural log of this cos, we're going to have cosine of what is theta minus what minus theta is equal to cosine u. What is our du? What's our theta? Perfect. It's what? Negative du. So I can put a negative here and the du stays here. Wait. So I can use this negative sign now to flip the limits of integrations. Right? I can flip it. Therefore, I'm now going to have the integral from 0 now to pi over 4 of cosine of u du. Great. So I see that I can discover that the integral from 0 to pi over 4 of cos of lim of cos of pi over 4 minus theta is thus these two integrals, this integral and this one are the same. Okay, because I'm seeing the integral from 0 to pi over 4 of cos u, right? This does look. This is the integral from 0 to pi over 4 of cos u. Then this is what? Integral from 0 to pi over 4 of cos theta, right? You can see that what? These two guys are the same. Okay? Yes, the two guys are the same. So I can just say that since the two of them are the same, their values are the same, note that this u and theta are just like dummy variables, okay? Yeah, so they do not change because the value of the integrals are the same, okay? Yeah, so I can just see a nice cancellation between this and this, okay? Yeah, I can just see a nice cancellation because I have investigated that the integral going from 0 to pi over 4 of cos u du is the same like the integral going from 0 to pi over 4 of cos theta. Yeah, so it's very difficult to see, but it's just hard to see, okay? Yeah, so you can just see a nice cancellation between these two guys. So in the end result, I'm going to clean this. So in the end result, now we're just going to have. So in the end result, I just have integral from 0 to pi over 4 of ln of 2 d theta. Yeah, so this, like I said, root 2 is a constant. So this one is just going to give us, like I can write this. Let me just say ln of root 2 times what theta, right? Limits are from where? From 0 to pi over 4. Yeah, so I'm not going to have ln of, or I can look at this with 2 as well as 1/2, right? 1/2 times that 2, right? Yeah, great. 1/2 times that, then theta times theta. So it now goes from 0 to pi over 4. Right, so I'm just going to have 1/2 ln 2 times pi over 4 minus 1/2 ln 2 times what? 0. This gives us what? 0. So in the essence, this integral now will just translate into what? We're just going to give me what? Gives me pi over 8 times the natural log of 2. This is the value of the integral. This is the value, okay? This is it because we're just going to have 2 times 4, which is what? 8, right? Then pi over 4. That. So this is the value of this definite integral. So please thank you for watching the video and like the video, okay? Please, most importantly, please subscribe to the channel. I want to thank extra all those who have subscribed to my channel. At least having the more subscribers motivates me that much to produce more interesting videos, okay? Yeah, so thank you, and share this video with your friends. Immediately after this video, I'm going to upload another, okay? Yeah, so thank you and see you in the next video.